In our most applications or in the beginning of our undergraduate electronics courses, we are familiar with the voltage source, but in many cases, a current source is more suitably applicable. For example, to drive a backlight LED, something like that, if you try to drive with a constant voltage, there could be a big variation depending upon the temperature and other variations and time to time derivations. Even a slight change in the voltage could lead to a big fluctuation in the light emitted from the backlight. So you could see temporal, spatial variations if you use a constant voltage source. So how do we get a constant voltage from a voltage source, and what's the circuit? This is a typical circuit that we use to get a constant current from using an op amp circuit. We will briefly look into how this circuit functions. So essentially we have a FET here, although a transistor could be used, and let's say if this is high, then the current flows through it. The key here is a very small resistor here, typically like 1 ohm or something like that, is used to collect the voltage here, and this voltage is fed back to one end of the op amp. The other end of the op amp is typically uh, governs the amount of the current flowing through this, and this could be a fixed voltage like a DC source, or it could be coming from a digital to analog converter, which in turn could be controlled from a microcontroller or a processor. But it could also come through a PWM. Then it's a, if we filter the PWM to get a DC voltage, that can be changed by the PWM's width. And then we could also use a kind of a variable potentiometer to give the key thing is that we need to have some voltage here that can be varied to change the current flowing, but once you set it, that current flowing through it stays constant, and we will want to see it how. So let's say whatever voltage x volt comes here, this one is compared with this, and let's say this current is, this voltage at this negative point is slightly less than this voltage. Then the op amp gives a higher feedback. That higher feedback leads to a higher current through it. Then that increases the voltage across this resistor, and that voltage coming here, it increases, and that it keeps increasing till this voltage becomes exactly equal to this voltage, and in that case there is no output, and there's no increase in the output, so that stays constant at that point. So by providing this loop, because this continuous loop, monitoring loop, we are able to make this current flowing through it a very precision constant current. There are few things we need to keep in mind. If we want to increase the current flowing through it, there are two ways we could do it. One is we increase the DC voltage here, which we can do using these three sources, or we could also increase this voltage, so or decrease actually this voltage. So if we change this voltage, the voltage collected from this resistor is changed. For example, if we reduce this current, this resistor, the voltage here will be less, and then the, because this voltage stays constant, this feedback voltage increase, and that will increase the current through this one. So reducing this resistor increases the current flowing through this our LED or whatever other circuit we want to make this current flow. Uh, there is a couple of more things. These resistors and capacitor circuit, it provides a kind of a loop back kind of oscillation. It prevents it, and it is done by using a kind of a filter thing with a cutoff frequency which is given by f is equal to 1 upon 2 pi r into c. So if you, so that's one thing you will need to watch for. Other than that, we need to look at this voltage level here. It should be suitably selected that should be higher than what you need to get this DC, this LED turned on. For example, you should consider the D to S voltage drop here, some voltage drop here, and if you are using any resistor here, some voltage drop here. If you use a too high voltage, then the current flowing, the D to S voltage will be too high, and this FET or the transistor get too hot. So you don't want to try to select a voltage that is too high than you need, but you also don't want it to be very low. For example, 3.3 volt here could be somewhat lower, or 3 volt could be somewhat low, because it won't put this LED into the conduction mode. So those are the between those two variations. You need to design it suitably. That pretty much covers the basic thing about a how to design a current source using an op amp. If you have any questions, you can put down in the comment section. Thanks.